Alright, welcome to your video right after unicircle and circular functions. Now, in this video, we are going to look at graphs of sine and cosine. Graph of sine and cosine functions. And one interesting thing is we will be explaining something called periodic functions. Periodic functions. Now, it's good for you to take note that many things in life repeat with a periodictable pattern. Repeat with a periodictable pattern. Prices of seasonal clothes. Price of seasonal clothes is one of these examples. And also, we can also have, and you see, all those things is because of the sine and cosine function that repeat their values. And they are periodic functions. So, when we say a periodic function, what are you saying? Now, it's not only prices of seasonal clothes. You see, there are sometimes price of seasonal clothes will rise up, sometimes comes down. You see that like that, okay? So those things are what we are linking up to a periodic function. Also, we can take an example that most of you are used to it. For example, like a temperature of a body. Alright? A temperature of a body. You can see that the temperature, when you visit a patient in the hospital, you can see that the temperature rise up, come down, rise up, come down. How you can see how it is very good. So when we say a periodic function, it's a function f. It's a function f such that f of s, which is equal to a function in terms of s plus n for every real number s in the domain of f, every integer n, and some positive number p. Alright, so it's also important for you to take note that the circumference of the unit circle, and we have learned a unit circle in our previous video. The circumference of the unit circle is 2 pi. So the smaller value of p, the smaller value of this p for sine and cosine function repeat is 2 pi. It's going to be 2 pi. Very good. Therefore, the sine and cosine functions are periodic functions of 2 pi. So don't forget that we are saying that the sine and cosine functions are periodic functions of 2 pi. That means that the period, okay, I don't want to use that word for now. Alright, so that's that. Now, let's continue to start from basic sine curve, the basic sine curve. Then after that, we go to the basic cosine curve, and we journey through all the trigonometric functions and their graph. Trust me, you are going to love it. Alright, so let's look at that of cosine. Let's look at that of cosine. So, as you know, the first thing to do is to go and grab your, is to go and take your table. So let's go for a table. Because you need a table to do the graph. So this will be the s, and this will be y is equal to cos x. Cos x. So this is a basic cosine curve. Cos x. And don't forget, take from 0. Then, as I said, when we're looking at sine curve, we established that even from 0 to pi on 2, we can get values there. We can get 15 degrees there, we can get 30 degrees there, we can get 35 degrees there, we can get 60 degrees there, and all that, which is pi on 12 is 15 degrees. We also have pi on 6, pi on 4, pi on 3, and all that. But all those values will be giving you decimals, okay? Will be giving you decimals. And it is all about increasing and decreasing. So you can choose to ignore that part. So let's bring pi on 2. Then the next will be pi. Between these values, between these arguments, we also have values there, but those values will be decimals. Then we go to 3 pi on 2, then we move to the last one, which is pi. And don't forget that the circumference of cosine and sine curve is 2 pi. Very good. Then after here, we start doing the substitution. So what will be cos 0? Cos 0 is going to give you 1. And cos pi on 2 is going to give you 0. Cos pi is going to give you negative 1. And this is going to give you 0 and 1. Now, you can realize from the table of sine curve that when you point sine 0, you are going to get 0. But you can see that here the cos is giving us 1. So for sine, when you plug in 0, the output is going to give you 1. For cos, sorry, for sine is 0, 0. So that is why it was starting at the origin, because we were having something like 0, 0. So that's why it was starting from the one origin. But this one is 0, 1. That means that this will not start from the origin. So you can see the difference between it even before we draw our curve. Alright, so let's go for the graph. Nicely drawn. As I said, you can ignore the, let me do that. You can ignore the negative part and start the 0 from here. Here is pi on 2. Here is pi. Here is 3 pi on 2, which is 270 degrees. Then here will be 2 pi. Very good. Then we are going to have 1 here because the least, the maximum is 1 and the least is negative 1. So here will be negative 1. Very good. Then we move on. At 0, what do we have? 1. So at 0 we have 1. So you can see that for sine curve, at 0 we have 0. So it starts from the origin. But with this, you can see where it's starting from. Very good. Then at pi on 2, we have 0. At pi on 2, we have 0. At pi, we have negative 1. At 3 pi on 2, we have 0. At 2 pi, we have 1. At 2 pi, we have 1. Oh, wow. So therefore, we start from here. So it will be decreasing, 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 decreasing up to 0. So you can see that when they start at 1, those values here, those 15 degrees, 30 degrees, the pi on 12, the pi on 6, the pi on 4, pi on 3, those values here, the output will be decreasing, 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 decreasing till it gets to 0. Very good. So it will be decreasing till it gets to 0. Then it continues to decrease again. So it gets to negative 2. Then it starts increasing, marvelous. Then it starts increasing. So it gets to 1. Then it ends there because that is 1 period. Don't forget, this is what we call 1 period. So the first period is 2 pi. So this is 1 period for sine. That is 1 period for sine. If you consider it again, it will be 2 period. It will be 2 periods. So this is just 1 period. Alright, very good. So that is going to be the graph for cosine. That's going to be the graph of cosine. So what are the next thing to look at? You see, right after looking at the curve of sine, then we establish the properties, right? So in the same way, we are going to do the same here. Let's look at the properties of the cosine curve. The properties of the cosine curve. I would like to dictate for you. Okay. Let's move on. Some of them is likely linking to the or sine. All right, so let's look at the properties of cosine curve. One, look at this graph and tell me. You can see that this graph is continuous on its entire domain. So the first property, that we can establish here is that properties of cosine. So for cosine curve one, the graph is continuous on its entire domain. The graph is continuous on its entire domain. Let's move on. That is negative infinity to positive infinity. Alright. But you can see that the range is negative 1 and 1. Okay. 2. Its s-intercept. Consider s-intercept. Its s-intercepts are of the form. Its s-intercepts are of the form 2n plus 1 pi over 2. 2n plus 1 pi over 2. If s-intercepts are of the form 2n plus 1 multiplied by pi over 2, where n is an integer. Alright, let's move to the third one. Here, allow me to dictate so that I can keep my marker. 3. Each period is 2 pi. Each period is 2 pi. Yeah. It is same for cosine. Yeah, it is same for sine. The period is 2 pi, and for this, the period is 2 pi. And also don't forget that it doesn't matter. Okay, I will tell you that. Let's end it. 4. The graph is symmetric to the y-axis. The graph is symmetric to the y-axis. Hope you can see that. Very good. But for sine, it's symmetric to the x-axis, so know the difference. The graph is symmetric to the y-axis. So the function is an even function. The function is an even function. Full stop. For all x in the domain, so here we are saying that the graph is symmetric to y-axis. And also we are saying that since it's symmetric to y-axis, then it means that the function is an even function. The function is an even function. And since it's an even function, that means that it is for all x in the domain, cos x is equal to cos negative x is equal to cos x. What this means is that if you have a negative argument, when you compute, the result is going to give you positive, no matter what is there. So that is called an even function because it's symmetric on the y-axis. Very good. So that is that for cosine. And we are saying that the period is 2 pi. Please, this doesn't matter even if you have cos bx. No matter what is here, the period is still 2 pi. We established that in the sine curve. So no matter what is here, it is still 2 pi for the period. Alright, and we will learn how to solve those in our subsequent video. Alright, so let's now move to graph of tangent function and the rest. Alright, welcome to this video. Now, in this video, we are going to look at how to graph a sine function. A sine function at origin and when it is translated. Alright, now, this is at origin. Alright, that is just sine x. The argument is x. Very good. Now, let's look at that. Now, you can see that here we choose values, the s value, that is argument. We choose from 0, pi on 6, that is 30 degrees. Then pi on 4, that is 45 degrees. Then pi on 6, that is 60 degrees. Pi on 2, that is 90 degrees. Pi, 3 pi on 2, and 2 pi. Very good. Now, when you just take your calculator, then you point that, sine of this, sine of that, and these are the values that you are going to get. Very good. Then after that, you come to the graph. Now, you can see that from the graph, let me first take it from the table. You can see that from the table we have 0 to 2 pi without the negative. It doesn't matter. Alright. It is the same thing, okay? If you are to go for the negatives on your table will be too lengthy. That's why. Very good. So all that we did here is that here you can see that from 0 to pi on 2. We have values within here. The 0 to pi on, because pi on 2 is 90 degrees. For what we have here, we indicated only 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And that is in the radian form. We normally write it in the radian form. Yeah, that's how we should be doing it. Alright, so the values between 0 and pi on 2, we can get pi on 6, we can get pi on 4, we can get pi on 3. But the result gives negative values. So those results is the ones here, alright? It is found within this and this side. Alright, so we say increasing. Now you can see clearly that this is 0.5. Now this increase to this, then this increase to this. So you can always see that this is greater than this will be greater than this, and this is greater than this. So you can see it starts from the 0, increase, and when it gets to this, don't also note that the range, it is bounded within -1 and 1. It is bounded within -1 and 1. So we have -1 and 1. Or let's write it 1 and -1. It is bounded within 1 and -1. So yeah, 1 and -1. So that is what we have there. So when it gets to the 1, then it comes down. So no need for us to be going for the values here, because we know that when it gets to the 1, it will be decreasing. So the values after this one will be decreasing till it gets to 0. And when it gets to 0, it decreases again till it gets to -1. Then it begins to increase. I hope you can see how it is. Very good. So for that one, it depends on you. I won't force you to bring the interval from here to here. It depends on you. Alright? So this graph, you can just make it like this. You can choose 0, pi on 2. Then we have pi. Then we have 3 pi on 2. Then we have 2 pi. You can do it as such and go your way. We know that at 0, here is 0. At pi on 2, here is 1, here will be 0, here will be -1, and here will be 0. Yeah, you can just choose it to be as such. What I indicated here is just to show you that we have values within 0 to pi on 2. But those values will be giving you decimals, and those decimals will be increasing. Then when it gets to the maximum height, then it will be decreasing, like that. So you can see that that is that. So now, what is going to happen on the right hand side? The same thing going to happen on the left hand side. So you can see that here it gets to -1. Then let me do it more. So here, this one will decrease to the -1. Then when it makes to the -1, it increase. It increase and pass through the pi. Then this one too will get to 1. You can see that this one will get to 1. And when it gets to 1, it decreases to 0. Alright, so that is that for the graph. Alright. Please, it's not compulsory, okay? When we are solving the questions, you get to know it. It's not compulsory for you to bring the negative part. You can even limit it to just this side, and you are correct. Okay. Thank you. So that is that for the sign. This is at origin. This is the one at origin. So looking at the graph here, we can deduce some properties. Right? We can deduce some properties. And let's see if we can get some of the properties. Alright, so that is the property. The first one, that is for sine, properties of sine function. The first one is that the graph is continuous over its entire domain. That is, it continues from negative infinity to positive infinity. And you know that the domain is for the x-axis and the range is for the y-axis. And the range, we have already said that it's bounded within 1 and -1, or -1 and 1, the same thing. Very good. Now, the second part is that its x-intercepts are of the form n pi, where n is an integer. That means that the n can be 1, it can be 2, it can be 3, it can be 4, it can be 5, it can go there up to infinity. Very good. And 3, each period is 2 pi. The period is 2 pi. The period of this is, now when you consider it on the negative, you say -2 pi less than or equal to is less than or equal to 2 pi. Alright? So for positive is 2 pi. For negative is -2 pi. That is that. For sine, the period is 2 pi. And when we say a period, I hope you know what we are talking about. That is, when it starts from 0, it ends at 2 pi. That is the period. 4. The graph is symmetric with respect to the origin. The graph is symmetric with respect to the origin. So the function is an odd function. The function is an odd function because when we say the function is an odd function, that means that when you choose an argument which is a negative angle and you punch on the calculator, the result is going to give you a negative result. So that is that for the properties. Alright, so let's move on to solve some questions and see what we can do. Alright, so let's look at this example. We are graphing the function in the form a sine x. Don't forget that what we previously did is just sine x. That's just sine x. Here, they're saying that what if we have a constant here? This constant can be 4, can be 5, can be 6, it can be anything. Let's look at what we have here. Graph y is equal to 2 sine x and compare to y is equal to sine x. Very good. So you are going to do your table in this way. We have sine x, then we have 2 sine x. Now we can see how it is. Now, when you punch on calculator, these are the values you are going to gain for sine x. And these are the values you are going to gain for what? 2 sine x. Now compare it. Don't forget that the range of sine x, the maximum is going to be 1 and the minimum is going to be -1. But for 2 sine x, you can see that the maximum is 2 and the minimum is what? -1. sorry, negative 2. Very good. So looking at what we have here, let's go and plot that and see. So we are going to have 1 and 2 and negative 1 and negative 2. Very good. So at 0 we have 0. Let's first do for sign S. At 0 we have 0. That means that it's starting at the origin. And at pi on 2 we have 1. At pi we have 0. 3 pi on 2 we have negative 1. At 2 pi we have 0. So graphing only this is going to give us and since that is not exactly what we are looking for, we are going to use dot dots. Okay, you can see what we have. Now we can link that to this, okay, knowing that this one will get to the negative 1, then it moves to here, then it gets to, it ends at that. Very good. And now I want to use dot dots. Very good. Now we move to the y is equal to 2 sin x. So for y is equal to 2 sin x, let's see 0 at x, 0 at y. So that one will start at origin. Then at pi on 2, it will get to 2. Oh, very good. At pi, it will get to 0. At pi, it will get to 0. So it's like this. Okay, let's finish first. At 3 pi on 2 is negative 2. At 3 pi on 2 is negative 2. At 2 pi, that is 0. So it moves this way. Oh, very good. Very good. And the same way, this will be like this. Get to the 2, pass through here, get to this here. Very good. So that I hope you can see. Very nice. Very nice. So that's how we do it. So we have this to be y is equal to 2 sin s. Then we have this to be y is equal to 2 just sin s. Very good. So that is that for that. That's that for that. So for a given value of s, the value of y is twice as larger as it will be for y is equal to sin s. As shown in the table below already, you can see that the a here will just it's just showing you how large the graph is going to be. Up you can see that here it has increased in maximum and the what and the minimum. So the only change in the graph is the range. The only change in the graph is the range, which is now becoming this is negative 1 1 and now this is negative 2 2. So the only change now here is the range. All right. So